When transitioning from conduit to exposed wiring, it is important to use a bushing or protector at the conduit end. The insulated bushings, typically made of rubber or plastic, are designed for this purpose. These bushings fit inside the conduit at the point where it transitions to exposed wiring. Their primary function is to provide insulation between the metal conduit and the wiring, preventing sharp edges from damaging the conductor insulation. This is crucial for maintaining electrical safety and preventing short circuits or other electrical hazards. Several types of conduits are acceptable for in-wall runs and similar applications. These can be broadly categorized as metallic and non-metallic conduits. Let's explore each category. Firstly, electrical metallic tubing or EMT is a thin-walled, galvanized steel conduit. It is available in both rigid and flexible forms. EMT is a common choice for residential and commercial electrical installations due to its relatively low cost and ease of installation. Secondly, intermediate metal conduit, or IMC, is a thicker-walled galvanized steel conduit compared to EMT. It offers higher strength and durability, making it suitable for applications where greater physical protection is needed. Thirdly, rigid metal conduit, or RMC, is a heavy-walled galvanized steel conduit. It is highly crush-resistant and is often used in outdoor or exposed locations where the conduit may be subjected to physical damage or harsh environmental conditions. Now let's look at nonmetallic conduits. 1. Polyvinyl chloride, commonly known as PVC, is a flexible, non-conductive plastic conduit. PVC is highly resistant to moisture, chemicals, and corrosion, making it an excellent choice for underground or damp locations. 2. Armored cable, often referred to as BX cable, is a flexible metal-clad cable with an insulated conductor core. BX cable eliminates the need for a separate conduit, as the metal cladding provides physical protection for the conductors. 3. Liquid-tight non-metallic conduit, or LFNC, is a flexible, water-resistant conduit. It is specifically designed for use in wet or hazardous locations where protection from moisture and chemicals is essential. When selecting conduits, consider the specific environment and application requirements. For example, in damp or corrosive environments, PVC or LFNC conduits may be preferred due to their resistance to moisture and chemicals. In areas where physical protection is a concern, IMC or RMC conduits may be more suitable due to their higher strength and durability. For exposed wiring on ceiling joists or similar locations, it is crucial to use insulated bushings or grommets to protect the wiring from sharp metal edges. These protective devices prevent damage to the conductor insulation and ensure electrical safety. It is also important to ensure that conduits are securely attached to framing or walls to prevent movement or damage. Proper support and attachment methods should be used to maintain the integrity of the conduit system. Always consult the National Electrical Code, or NEC, for specific requirements and best practices related to conduit installations. The NEC provides detailed guidelines on conduit selection, installation methods, and safety requirements. Adhering to the NEC ensures that electrical installations are safe, reliable, and compliant with industry standards. Different types of EMT fittings exist to connect sections of EMT conduit and attach them to electrical boxes or enclosures. Common EMT fittings include couplings, connectors, and set screw fittings. Couplings are used to join two sections of EMT conduit together, while connectors are used to attach EMT conduit to electrical boxes or enclosures. Set screw fittings use screws to secure the conduit to the fitting. IMC fittings are designed for use with IMC conduit and provide a secure and reliable connection. These fittings are typically threaded and are available in various configurations, including couplings, elbows, and connectors. RMC fittings are similar to IMC fittings but are designed for use with RMC conduit, which has thicker walls and requires more robust fittings. PVC fittings are specifically designed for use with PVC conduits and are typically glued or threaded to provide a watertight seal. These fittings are available in a wide range of configurations, including couplings, elbows, T's, and adapters. When working with electrical conduits, it is important to follow proper safety procedures and wear appropriate personal protective equipment. This includes safety glasses, gloves, and insulated tools. Always to energize the circuit before working on any electrical components and verify that the power is off using a voltage tester. When cutting conduit, use a proper conduit cutter or saw to ensure a clean and accurate cut. Deburr the cut ends of the conduit to remove any sharp edges or burrs that could damage the conductor insulation. When bending conduit, use a conduit bender to avoid kinking or damaging the conduit. Follow the manufacturer's instructions for the conduit bend and ensure that the bend radius meets the NEC requirement. When installing conduit in wet locations, use watertight fittings and sealants to prevent moisture from entering the conduit system. This is especially important for underground installations or locations where the conduit may be exposed to rain or water. When running conduit through fire-rated walls or floors, use fire-stopping materials to maintain the integrity of the fire barrier. This helps prevent the spread of fire and smoke in the event of a fire. When supporting conduit, use appropriate hangers, straps, or clamps to secure the conduit to the building structure. The support should be spaced according to the NEC requirements to prevent sagging or damage to the conduit. When grounding conduit, follow the NEC requirements for grounding and bonding to ensure a safe and effective ground path. This helps protect against electrical shock and prevents equipment damage. Always inspect the conduit system after installation to ensure that all fittings are tight, supports are secure, and grounding is properly installed. Correct any deficiencies before energizing the circuit. If you are not familiar with electrical conduit installations, it is best to consult with a qualified electrician to ensure that the work is done safely and in compliance with the NEC. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents or injuries. Different types of conduit bodies are available for making bends, splices, or changes in direction in a conduit run. Conduit bodies, also known as conduits, are typically made of metal or plastic and are available in various shapes and sizes. Common types of conduit bodies include LB, LL, LR, and T types. LB conduit bodies have an opening on one side and are used for making 90-degree bends where the conduit enters a box or enclosure from the side. LL and LR conduit bodies have openings on the left or right side, respectively, and are used for making 90-degree bends where the conduit needs to turn to the left or right. T conduit bodies have 3 openings and are used for making a T-shaped junction in a conduit run. When selecting a conduit body, consider the size and type of conduit being used, as well as the specific application requirements. Ensure that the conduit body is compatible with the conduit and fittings being used. When installing conduit bodies, follow the manufacturer's instructions and use appropriate fittings to ensure a secure and watertight connection. Support the conduit body properly to prevent stress on the conduit system. Always inspect the conduit body after installation to ensure that it is properly aligned and securely fastened. Correct any deficiencies before energizing the circuit. Different types of sealants and adhesives are available for sealing conduit joints and fittings to prevent moisture or gas from entering the conduit system. These sealants and adhesives are typically applied to the threads of the fittings before they are tightened. Common types of sealants and adhesives include Teflon tape, pipe dope, and silicone sealant. Teflon tape is a thin, non-adhesive tape that is wrapped around the threads of the fitting to create a watertight seal. Pipe dope is a paste-like sealant that is applied to the threads of the fitting to create a gas-tight seal. Silicone sealant is a flexible, waterproof sealant that can be used to seal conduit joints and fittings. When selecting a sealant or adhesive, consider the type of conduit being used, as well as the specific application requirements. Ensure that the sealant or adhesive is compatible with the conduit and fittings being used. Follow the manufacturer's instructions when applying the sealant or adhesive. Allow the sealant or adhesive to cure properly before pressurizing the conduit system. Always inspect the sealed joints and fittings after installation to ensure that they are leak-free. Correct any leaks before energizing the circuit. Different types of grounding bushings and lock nuts are available for grounding metal conduit to electrical boxes or enclosures. Grounding bushings and lock nuts provide a secure and reliable connection between the conduit and the grounding system. Grounding bushings have a set screw that is used to bond the conduit to the grounding conductor. Grounding lock nuts have a sharp tooth that bites into the metal of the box or enclosure to provide a grounding connection. When selecting a grounding bushing or lock nut, consider the size and type of conduit being used, as well as the specific grounding requirements. Ensure that the grounding bushing or lock nut is compatible with the conduit and electrical box for enclosure. Follow the manufacturer's instructions when installing the grounding bushing or lock nut. Tighten the set screw or lock nut securely to ensure a good grounding connection. Always inspect the grounding connection after installation to ensure that it is properly bonded. Correct any deficiencies before energizing the circuit. Different types of cable trays and supports are available for supporting and routing electrical cables and conduits. Cable trays are typically made of metal or plastic and are available in various sizes and configurations. Common types of cable trays include ladder trays, solid bottom trays, and wire mesh trays. Ladder trays have rungs that support the cables and allow for ventilation. Solid bottom trays provide continuous support for the cables and prevent them from sagging. Wire mesh trays are lightweight and flexible and allow for easy cable access. Cable supports are used to suspend or mount cable trays to the building structure. Common types of cable supports include trapeze hangers, wall brackets, and floor supports. When selecting cable trays and supports, consider the size and weight of the cables and conduits being supported, as well as the specific installation requirements. Ensure that the cable trays and supports are properly sized and rated for the load they will be carrying. Follow the manufacturer's instructions when installing the cable trays and supports. Support the cable trays properly to prevent sagging or damage. Always inspect the cable trays and supports after installation to ensure that they are properly aligned and securely fastened. Correct any deficiencies before installing the cables and conduits. Different types of fire-rated sealants and foams are available for sealing penetrations in fire-rated walls and floors to maintain the integrity of the fire barrier. These sealants and foams are designed to prevent the spread of fire and smoke in the event of a fire. Fire-rated sealants are typically intumescent, meaning they expand when exposed to heat to fill the gap around the penetration. Fire-rated foams are lightweight and easy to install and provide a good thermal barrier. When selecting fire-rated sealants and foams, consider the size and type of penetration being sealed, as well as the fire rating of the wall or floor. Ensure that the sealant or foam is compatible with the materials being penetrated. Follow the manufacturer's instructions when applying the sealant or foam. Allow the sealant or foam to cure properly before exposing it to fire. Always inspect the sealed penetrations after installation to ensure that they are properly sealed. Correct any deficiencies before occupying the building. The National Electrical Code Section 300.4 addresses protection against physical damage. It says that where subject to physical damage, conductors, raceways, and cables shall be protected. This can involve using heavier gauge conduit, installing barriers, or recessing the wiring. Section 300.5 covers underground installations. It dictates burial depths for different wiring methods and voltage levels. It also addresses protection from damage by rocks, soil movement, and other factors. Section 310.15 covers ampacity, which is the current carrying capacity of conductors. It provides tables and guidelines for determining the allowable ampacity of conductors based on their size, insulation type, and installation conditions. Section 314.17 deals with the number of conductors allowed in a box. It outlines rules for calculating box fill based on the size and number of conductors, devices, and fittings in the box. Section 330 covers metal-clad cable, also known as MC cable. It specifies the permitted uses, installation requirements, and ampacity of MC cable. Section 334 covers non-metallic sheath cable, commonly known as Romex. It outlines the permitted uses, installation requirements, and ampacity of non-metallic sheath cable. Section 344 covers rigid metal conduit, or RMC. It specifies the permitted uses, installation requirements, and dimensions of RMC. Section 348 covers electrical metallic tubing, or IMT. It outlines the permitted uses, installation requirements, and dimensions of EMT. Section 352 covers rigid polyvinyl chloride conduit, or PVC. It specifies the permitted uses, installation requirements, and dimensions of PVC conduit. Section 356 covers liquid-type flexible nonmetallic conduit, or LFNC. It outlines the permitted uses, installation requirements, and dimensions of LFNC. Section 358 covers electrical metallic tubing, or INT. It provides the requirements for installation and support. Note the correct support intervals. Section 370 covers cable trays, which are used to support and route cables. It specifies the requirements for cable tray construction, installation, and grounding. Section 392 covers cable bus, which is a system of insulated conductors installed in a ventilated enclosure. It outlines the requirements for cable bus construction, installation, and ampacity. Remember, always consult the latest edition of the NEC for the most up-to-date requirements. Improper electrical work can create fire hazards and electrical shock risks.